Okay, so what exactly is volume? Like, don't tell me the formula, but what does it mean?
The area inside the space inside.
That's the word I'm looking for right there, space. So volume is the space that an object takes up. Okay, so it's not just the outside. If you think about a box, it's not just the box, it's what's inside the box, okay? It's how much it will hold, all right? So we have now been finding area of flat, two-dimensional shapes. We are now moving to three-dimensional, and we're talking about volume. So, of course, we're going to be using three different dimensions. So our formula is what? You got it. Length times width times height. Now, here's the thing. Be careful. Don't use a lowercase regular L. You need to use a cursive because we don't want it to look like a 1. And you don't want to use a capital L because capital letters will stand for other things farther down the road. I'll give you an example of one in just a minute. But you want to use a cursive L for length times width times height. Okay? Now that we have moved into three dimensions, all of our answers for volume are cubed. So instead of squared like area to the second power, they're going to be to the third power. Exactly. The one thing I want to tell you about the formula, as you progress through math and you get into harder classes, you'll notice the formula for volume will become capital B times H. And what that capital B stands for, you know?
The complete base, which is length times width.
Exactly. So it's the area of whatever base you have times the height. Because I want you to think of volume like you have this box, okay, and we're stacking little boxes inside of a bigger box. So you've got the bottom row, and the bottom row may have an area of 12, but you've got 4 rows, so what would your total volume be?
12 times 4.
Which is?
48.
48, absolutely. So, to me, one of the easiest ways I think about it is if you go buy a 12-pack of Cokes, all right? We're going to talk about the cans are going to be our measurement. So if we look at the bottom row, it's a 1 by 6 because the bottom row has 6. So your area for the bottom row would be 1 times 6. But there's 2 levels, so it would be 1 times 6 times 2. That's where you get your formula.
Or 6 times 2.
Right, so this base right here for us, because this year all we're dealing with are rectangular prisms, okay? So this base right here is represented by length times width. As you get older and you're going to be finding the volume of, say, a cylinder or something that looks like a Pringles can, you would find the area of the circle and then multiply it by the height, okay? So you'll get into that in 7th and 8th grade. No. I'm not exactly sure. I'd have to go back and double check, but I will look that up to see. But anyway, so what I want you to understand is this formula comes from, gentlemen, us finding the area of the base, okay? So looking at this shape, what would our base be? Oh, I mean, most of the time we want to say the base is the bottom, right? Okay, so what shape is here on the bottom? A rectangle. Now, for us, this year, since all we're doing is rectangular prisms, our bases will always be a rectangle, okay? So if we look for our measurements here, what 2 measurements are we going to use to find the area of this bottom? 4 and 10. Because look, if this is 10, this is 10. If that's 10, this is 10. So we do 4 times 10, but we want the whole box. So how tall is it? 5. So that's why we do 4 times 10 times 5. So volume is 40 times 5, which would give us 200, and that is inches cubed. Because remember, we are now 3-dimensional shapes. Okay? As of now. Yeah. Just as of now. Yep. Do what now?
4 times 10 and then do 4
If you want to do it in one step, that's fine. Yeah, I was just walking you through each one. That's fine. All right, now, the other thing I want us to talk about real quick, okay, is finding the missing measurement. So, again, we start off with our formula, just like we did when we had area. Volume equals length times width times height. And like we did when we were doing algebra, I'm going to plug in what I know. All right? So looking at this, what is my volume?
890.
You got it. So I'm going to plug that in for V. Okay, my length is 9. Do I know what my width is? No. So I'm going to leave that a W, and this is all times. And then my height is what? 7. Okay? So if I do this, 819, is there anything I can go ahead and take care of here?
9 times 7.
I can. Does it matter that there's a W in the middle? No, because we can mix those around. Multiplication of commutative property, you got it. So we're going to do 63 times W. And now we're back at that point like we were in algebra where we have a multiplication equation. How do we undo multiplication? Division. So I'm going to divide both sides by 63. So what would our width be? Somebody would divided by 63. Somebody 13, you got it? So that is 13 feet, and it's not cubed because we were going backwards. We already know our volume, we're missing one of these guys, so it's just going to be 13 feet. It's not going to be cubed. Yes? That's what we did, but if you put it in that way, if you do 9 times 7 divided by that, you're going to get, because you're not doing 63 divided by 819. Okay, what I'm giving you now, if you will go ahead and put this sheet, the one that we just finished, in your math workshop, each day we're going to do a couple of review problems. And that'll be what we're going to do for math workshop this week. Oh, I know, I'm still recording, I'm good. So what I'm giving you now is what we're going to go over. This is what we're going to go over for today. Please stop drumming. Okay, when you get this sheet, I want you to look at the side first. It has the 3D shapes on it. Okay, so everybody take a look at this side. Now, we are pretty good at naming 2D shapes. Like you had the rectangle, trapezoid, parallelogram, triangle, and then a couple of others. Square, there you go. But now we're going to move on to 3D shapes. There are two ways that you classify a 3D shape. That's based on its base and its sides, what the sides are doing. Okay? So when we look at the first one, anytime I have sides of a shape that come to one point, what does that look like?
A triangle. It's a pyramid. It looks like a pyramid.
It does look like a pyramid. Pass it over there. All right, it does look like a pyramid. But here's the thing. Look at the base. It's not a square. What is this?
A triangle. Rectangle.
Not yet. It is a rectangular pyramid. Okay? It is based, or it is classified by its base, which is a rectangle, and then by its sides, which are triangles that come to a point. So that one would be what we call a rectangular pyramid. Okay? So looking at the second one, what's the difference in the second one? Right. The base is a triangle instead of a rectangle, so now it becomes a, you got it. So now we have a triangular pyramid. Okay? Your pyramids will always come to a point. Okay? Looking at the next one, that's like our Pringles can. Cylinder, you got it. And number 4 should be pretty easy. Cone. Okay. Next one is not a circle, it's 3D, so it is a sphere. Okay, let me remind some of you back there, I am still recording. Okay? All right, now, number 6. Based on our sides, they come to a point, so we know it is a pyramid. But look at the base. Great thought, but it's not squarular. Whenever your base on a pyramid is a square, it is a pyramid.
That one important.
We're good.
Did you break the chair?
All good. Okay, when your base is a square, it is just a pyramid. All right? Your sides still come to the point, but when your base is a square, it is just a pyramid. And the reason is because all of my sides are now exactly the same.
I know what the next one is.
All right, hold tight, hold tight. Okay? All right, what about the next one? What do you think?
It's a triangular prism.
You are correct. This is a triangular. The next time you are in a grocery store or Walgreens or wherever they sell like lots of different types of candy bars, there's one you can look for that is the perfect Toblerone.
I was going to say it starts with a T.
Yes, it is a perfect example of a triangular prism because it has triangles on the end and it's a long box.
Does it have a bear on it?
It's a yellow box with red writing is all I remember.
Why do I know
Okay.
what there's a bear in it, but not what it's called?
I did that because you're used to the branding. That's it. Okay, looking at this one, what do we think, guys? Rectangular prism. You got it. Again, the difference between the prism and the pyramid. Pyramid comes to a point. Prism has all sides that are rectangles. All right, and when all of your sides, let's use the correct term. When all of your faces, because remember the sides of a shape are called faces. When all of your faces are squares, it is a cube. You got it. Okay, so it is not only important that you recognize these shapes when they are put together like this, but now we're going to shift sides and we're going to talk about something called a net. What happens if, there you go, that's right. What happens if I take a net, like a fishing net or anything, and I toss it over a box? What shape does it take?
The box.
The box, okay? So that's theoretically why these are called nets, because they're unfolded. Raise your hand if you think your cereal box has 3 or more pieces of cardboard putting it together.
It's just one.
You are wrong.
Oh, it's one.
It's one.
They
It is
folded.
one piece of cardboard that is just folded. So your cereal box is a net. You can take your box and unfold it. Absolutely. So that's what these are. And they're called nets because when they're folded over something, they will take the shape of the shape that it's in it. Okay? So if we look at this one, and this is where my visual learners tend to do really well because they can visualize folding these up. If we were to fold this up, what would we have? A cylinder. Okay, everybody back to me. Look, if I fold the circles down and then wrap the rectangle around, it makes a cylinder. What about this one? Cone. All right. What about this one? Cube. All right. And then this one. Very good. Triangular pyramid. Okay. What about the next one? Pyramid. Very good. Remember, when the base is a square, it is just a pyramid. Okay, this one is not a cube. What would it be? Very good. Rectangular prism. Okay. This one?
Triangular prism.
There we go. There's our candy bar box. And the very last one, rectangular. Be careful. Pyramid.
Tanner, why? We already did rectangular.
So that one is a rectangular pyramid. Now, when we have these shapes unfolded, the part that's unfolded is everything that will be on the outside. It's like the shell of the shape. Okay? So when we talk about the surface of something, the surface is what?
The outside.
The outside, the top. Okay? It's the part that if you were to pick up a shape, it's everything you're touching. That's the surface, okay? So let's look on the back. What we're going to be doing is taking these nets, and now we're going to jump back. We're going to forget about volume for a little while, because volume is what is on the inside. Now we're going to talk about the outside shell. We're going to find the surface area of the outside. This is very similar to what we did 2 weeks ago when we did compound figures. Remember when we had to split the shapes apart and then add them back together? Okay? Except now our shapes are already split for us.
Now we have to add.
All we got to do is add them back together. Okay? So, first of all, what shape is this?
A triangle.
Triangular prism.
See, I'm good with shit.
Okay? So, I have 3 rectangles and I have 2 triangles. Looking at these triangles, these lines, remember, mean that all 3 of those sides are the exact same. So if this side is 3, what's this side?
3.
Okay? And if this side's 3, what's that? 3. Okay? The great thing about these nets is that we know they have to fold together to form a shape. So we're going to have a lot of symmetry. Absolutely. They've got to be the same. If these 2 triangles weren't the same, we wouldn't have our neat little nice triangular prism of a shape. Okay? It would be uneven. The box would not work. Okay? So here we go. We're going to use our formula for rectangle to find the area of a rectangle. So what 2 measurements am I going to use?
3.6.
Right here, we're going to do 3 and 11
I didn't see it.
because we got 11 times 3, so the area of the rectangle is 33. But what that means is this one's 33, this one's 33,
And that was 33.
you got it.
33, 99.
So then here we go. We got to find the area of our triangles, which is base times height divided by 2. And we know our base is 3. Our height is, height is not 3, it is 2.6. And all of that divided by 2. I'm going to let y'all do that on your calculator real quick.
7.8.
All right, divided by 2.
Oh, yeah.
7.8 divided by 2.
It
Yep.
would be.
Wait a minute.
What would it be? 3.9. Okay? So what this means is this triangle is 3.9 and this triangle is 3.9. So now, to make this work, I've got to go in and add all 3 rectangles and both triangles. If I have 3 that are the same, can I just multiply?
So it'd be 99.
99, and then someone do plus 3.9 and plus 3.9. What'd you get? 106.8. And that is inches, and this time we are squared because we're going back to area. This is surface area. This is all flat. We have unfolded these shapes. Keyword area. Very good. Okay? So it's kind of like you've already done this. Now you're just doing it with actual specific shapes and not random shapes. All right, looking at number 2, what type of shape?
Triangular prism.
Triangular pyramid. Be very careful. Good.
You want proof?
All right, here we go. The great thing about this, if we look in the middle, this is what we call an equilateral triangle. All 3 sides are the same. Okay, so that means if this side is the same as this, is the same as this. So when I have an equilateral triangle as my base, what happens to the other 3?
They're all the same.
They all have to be the same. So all we've got to do is find the area of 1 and then multiply by how many?
4.
4. Because you've got 4 faces. 1, 2, 3, 4. So my base is 7.2. My height is 5. All of that divided by 2. What'd you get? 18? Yep. So now that means each of these triangles is 18. I do like to, you don't have to do this, but I do like to go back in the shapes and write what the area is. And since I know there's 4 of them, I'm going to go over here and multiply that by 4.
72.
Very good. And that's millimeters squared.
Square.
See, this is not so bad. Good. Believe it or not.
hard.
Okay, let's look at number 3. What type of shape? Pyramid. Very good, because the base is a square. Okay? So if the base we know is a square, if this is 4.5, what's this? 4.5. Okay? So I've got to go in and find the area of my base. So that would be 4.5 times 4.5. Somebody want to do that for us? What'd you get? No add. Got to multiply. 20.25. Okay? So that's our square. 20.25. Okay? And looking at our triangles, because it's a square, again, anytime you have a pyramid and all of these bases are the same, they all have to meet together at the top, so all of our triangles are the same. So we got base times height divided by 2. No, because my base is 4.5 and my height is what? 8. Okay, so 4.5 times 8, 36, divided by 2, 18. We like 18 today, don't we? Alright, so there's 18 in each of these triangles. The reason it's not half of your square is because your height is different on each of them. If you'd had a height that was the same, yeah, you could have done that, but not.
Why are all these triangles?
I know. Alright, so how many triangles do we have? 4, so I can do that times 4. Alright, and then we add the square. You got it, 92.25, and that is centimeters squared. Everybody feeling good so far? Okay. You just have 4 problems. That's it. Alright, so last one. This hopefully should be the absolute easiest. It is a cube. That's right, because it is a cube and these are all squares. Every single side is 14. How many faces does a cube have?
6.
Very good. So areas, base times height. That would be 14 times 14, which is, what'd you get? Nope. 196? Okay. Now, because we have 6 sides that are all the same, can we multiply that by 6? 1,176, and that is feet squared. Okay? That is a big cube.
I hope we only have cubes.
Wouldn't that be great? Alright, I'm going to go ahead and stop this.